Salam and very good day. Today we will continue our lessons, knowledge sharing about internal rate of return that we will be used for our engineering economic decision making. Let's say an example of this IRR calculation. Okay, an opportunity arise which require 5,000. Okay, earlier investment. Okay, we invest first, and then after that, later from year 1 to year 10. Okay, here from year 1 until 10 years. Okay, 100 will be paid to us, will be collected each year. And then at the end of year 10, we also will get paid another 7,000. Okay, will begin. So, based on this cash flow diagram, analyze the relevance of the deal. Let's see the solution for this example. What we need to do here is we must construct our equation for the NPV here. In our case here, our NPV is equivalent to, alright, negative 5,000. Okay, negative 5,000 because we use the money plus 100. Okay, 100. This is A because we want to know what happened here. This is NPV. Okay, we want to know what happened here at present worth present day. So we call those as finding P when we know the A. Okay, we transfer it here. Alright, so this will become 100 multiple to finding P when you know the A at I interest rates of 10 years. Okay, because we got paid up until 10 years. Alright, plus the 7,000. Where is this 7,000? Yeah, this is the 7,000. Why is this 7,000? 7,000 here is F here. F. And then because we want to know what happened to this value in this present day, we call those as finding P when you know the F. Okay, multiple to 7,000 here. Right, very straightforward this equation. And then we will construct our table. Okay, one column, two column. Okay, this is to calculate finding P when you know the A, and then this is to calculate the finding P when you know the F, and then this NPV is to calculate what is the exact corrective amount for the NPV. Alright, so let's see. We got this equation. We got construct the table there. Let's say I'm greedy enough. Okay, I want more money. So I put 20% first. Yeah, as our interest rate. Okay, I want 20%. After that, I'm open the compound interest table. I take the finding P when I know the A at year 10, and then I will put inside our equation. Okay, I got 4.19 to 5 multiplied by 100, and then I will take from the compound interest table finding P when I know the F at year 10. I put the value in our equations here, and then I will see that, wow, our NPV here is negative 3,000. Negative 3,450. Straightforward, we know. It is impossible to get 20%. So I'm lowering down my expectation. I'm saying, okay, there's no chance for me to get 20%. I just put here 5%. Okay, interest rates. And then when I'm opening the compound interest table, and then I replace the finding P when you knew the A at year 10, okay, 7.7, okay, here, and then for finding P when you knew the F at year 10, okay, we will got 0.6139, and then wow, yeah, we got positive number here. Okay, positive 69. Okay, if we use the 20%, we got negative figure. Okay, if I enhance my calculation, let's say I put 6%, because our first calculation here 20% will give you too much negative there, 3,450. So I just put another 6% here. Alright, 6%. I put the finding P value the A, the value of 7.3, and then finding P value the F at year 10, okay, for 6%, 0.5584, and then we'll see, okay, yeah, it is much closer to 0 there. Our negative will become, let's say this is 0, okay, this is 0, so will become much more closer to our 0, our negative there, 355. Okay, previously is 3,450. Alright, our positive value will give you around 69 there. Alright, 69. Okay, so the next thing to do is we will interpolate the closer value here. The closer value here is around 5 to 6%. Okay, so I minus 6 divided by 5 minus 6 equal to 0 minus negative 350. Okay, divide by 69 minus the negative 350, and I will see that, yeah, from this interpolation will give you around 0 here. The value of your interest rate is 5.16. Okay, way below from our expectation, 20%. Okay, so for each of our business deal or trading deal or project deal that we take, it will give you only 5% margin, 5% profit after 10 years. So this value representing a potential 5.16 of IRR after 10 years, when earlier sum of 5,000 was spent at earlier years. It is, however, quite competitive investment comparing to saving in any financial institution. Okay, majority will give you 4 to 6%. If I'm will be you, I will accept the investment opportunities. Let's see another example of this IRR problem. All right, an opportunity arise which require 6,000 earlier investment. Okay, 6,000 earlier investment in engineering sector. However, there is requirement to invest gradually from year 1, okay, from year 1 up until year 17. Okay, gradually, right, in value of 10. And then after that, a large sum of gain will be collected at the end of year 17, 21,000 here. So based on this cash flow diagram, analyze the relevance of the investment. Alright, first thing first, we need to having our equation, NPV equation. Alright, the NPV equation is developed from our cash flow diagram. Alright, this is the 6,000. Alright, negative, and then we also need to invest gradually for 17 years. Okay, we need to divide this G here, gradual investment here, to become two. The first one is for your per annum. Okay, and then the second one is just for your gradient calculation. All right, for the first A here, the value is 80. Okay, finding P when you knew the A. So we want to convert this A to become present value today. Okay, that's why we call it as finding P. Okay, when you know the A. All right, and then after that, also second calculation from our divisions of gradient there, we calculate for finding P. Okay, finding P present day when we knew the G. So what is the G there? G is 90, okay, minus the 80. So we got the gradient there in amount of 10. Okay, once we understand this, so we can put finding P when G here. Alright, and after that, we convert this value. Okay, we gain 21,000. This gain is in the form of F. Okay, in the future. So if you want to convert this to become this present value, so we call those as finding P when you know the F. Alright, and then insert it inside of our NPV equation. Alright, 21,000 multiple to finding P when you know the F. Alright, once we got this understanding, this equation, so we need to construct our table. Okay, column 1, 2, okay, finding P when you know the A, another here. Okay, another column here, finding P when you know the G here. Okay, and then finding P when you know the F. Alright, and then the sum of our NPV. Alright. Okay, let's say I'm not confident about this investment, so I just put, yeah, maybe 1% investment first. Okay, of all costs that I give, I'm not confident about this investment opportunity, so I just put 1%. Okay, so I'm opening the compound interest table at 1%, and then finding the value of P over A, finding the value of finding P when you know the G, and then finding the P when you know the F. Okay, and then I insert all of this value in our equation here, and then I will see that our NPV value will become 9,000 here, 9,000. All right, so I can put after that maybe 4%. All right, I can put 4%, and then I put all of P over A, P over G, P over F value in our NPV equation, and then we will see that our NPV still very large sum of positive 2,900. Okay, and then we put extra effort at 6%. Okay, and then we replace all of the value P over A, P over G, and P over F for this NPV equation, and then you will see at 6%, our NPV will give you only 267. We already close to our zero value, and then we put another value of I interest at 7%. Okay, we replace all of P over A value, P over G value, P over F value in our NPV equations here, and then we'll see, yeah, at 7%, our NPV will getting negative 758. All right, so we take the interpolations of the closer value. In our case here, the closer value is around 6 to 7% to gain between the positive, 0, and negative value. Okay, we need to take the closer value. All right, so in our case, I minus the 7%, okay, divide by 6 minus 7% is equivalent to 0 minus 758. Divide by 277 minus the minus 758, and then you will see that after we interpolate this, okay, see our value will become I 6.26%. Okay, between 7 to 6% interest rate. So this value is representing a potential 6.26 of IRR after 17 years, when 6,000 was spent at earlier years. For me, it is quite competitive investment comparing to saving in any financial institution, because financial institution can give you maybe around 4, okay, 4%. All right, except the investment opportunity. Let's see another example for this IRR problem. An opportunity arise which require 25,000. Okay, 25,000. Earlier investment in this engineering sector. After that, fixed maintenance fee of 500. Okay, we call as per annum here. All right, 500 every year for 3 years. All right, for 3 years. And then there is also requirement to invest separately from year 1 to year 3 there. All right, 5,000. Okay, at first year, at second year, another 1,000, and then at the third year, another 800. Okay, respectively. Then a large sum of gain will be corrected at the end of year 3, an amount of 35,000. Okay, based on our cash flow diagram. All right, analyze the relevance of the investment. Let's see the solution. As usual, what we did is we need to develop an equation for the NPV. All right, so the first thing is this 25,000 is our present value of money. All right, so it become like here, and after that we need to pay 5,000, 1,000, and 800 at the first, second, and third year of our investment. Okay, so this 5,000, this is our F1, okay, future 1, and then the 1,000 is our F2, future 2, and then our 800 here will become our future 3. Okay, and then all this we need to transfer it here at our present day. All right, at our present day. Okay. So according to our NPV here, all of this, all right, will be developed as 5,000 multiplied by finding P when we know the F. Okay, so finding P when we know the F1. All right, and then after that minus 1,000. Okay, minus 1,000 multiple by finding phi, okay, when you know the f2, okay, and again minus 0.8 here, multiple by finding phi when you know the f3, yeah. Alright, and after that we also need to transfer our per annum here to become present value here at year 0 here, present value. So in our case here, 0.5, okay, thousand is multiple to finding P, okay, when you know the A. Our A is 500 here. Alright, and then after that, lastly is our 35,000 here. This is our F4 here, okay, F4. So this will become finding P, okay, this will become 35,000 multiple to finding P, alright, when we know the F. Alright, so once we're having this equation, what we need to do now is to develop our table, okay, consists of our interest rate, okay, and then P over F, okay, P over F, because we have 1, 2, 3, P over F there, okay, and then the next column we will have uh, P over A here, alright, P over A here, and then last, okay, but not least, our NPV value, yeah, alright. So if we seeing the here, uh, we try to use first our 5% interest rate here, and then we will see that if we insert from value from our compound interest table, alright, P over F for 1 year, okay, 0.9524 here, alright, here, and then P over F for second year here, alright, and then P over F for 3 years, we can use both here, no problem, okay, no problem, and then P over A, this value, we take it from compound interest table for 5%, and then we will see that our NPV after we insert all of those value, we got negative 2, okay, negative 2.4, and then we know exactly once we got this negative value, so the interest rate is lower, okay, is lower compared to the zero value. So we need to lowering down our interest rates from 5 to less than 5. In our case here, I try to use 2% first, okay, and then I'm refer back to compound interest table, and we insert the value for first, second, and third year from our P over F, P over F, and P over F, okay, and again P over A for each of those, and then P over F here, and then I will see that our NPV here, if we use 2% interest, okay, we still can get positive value, okay, we are in a negative value. However, we know that the value is almost closer near to 0, so we directly know uh, this is not a very good investment. However, for the sake of learning, we try to use another value, okay, in our case here I try to use the 1%. So if I'm using the 1% and then I put it from the compound interest table value, okay, for first year, second year, third year, Okay, or for the P, finding P we knew the F, and then for the finding P we knew the A. Alright, and then we see that wow, the interest rate, the NPV by using the 1% interest rate is positive 2. Yeah, and then we interpolate uh, the information, the value, and then we will see that uh, our value, our interest rate that we can collect is just 1.97%. Right, too low. Alright, too low. After 3 years, we only get 1.97% when 25,000 is spent at our earlier years. Okay, of course, it is not competitive investment comparing to any saving in any financial institution. Okay, because this financial institution, for example, if we save in their fixed deposit, easily we can get 4%. So there's no need to invest in this project. They can give you just 1.97. Better you save your money in the bank if this project appear, okay, this opportunity appear to you. Reject it. Okay. So we already learned about the internal rate of return or IRR here. A few notes we need to share. All right. IR is playing an important role for engineers, technicians, managers to ramp general rates of return. Okay, so the present worth of money is compared to its equivalent in the near future, and the highest IR contributed by selected investment is preferred. However, there is a limitation of its applications because IR work best for initial investment, which having cash outflow, capital, machinery, etc., and followed by cash inflows. Alright, and IR not describe the whole investment size and its return. Alright, so IR is only considered the most rates of return, although the amount of money is relatively small. For example, a returning of $50 or ringgit from $10 or 10 ringgit investment will gain more IRR compared to that 10 million investment returning 15 million. Okay, and IR also required a same durations of project investment time period for comparison purpose. That's mean IR is very useful for equity investment and venture capital analysis, which utilize multiple cash investment in the overall business activity. Alright, and later a sales, for example, sales of the business machinery, salvaging, IPO, etc., which contributed for a single cash outflow will complete the overall life cycle. Alright, thank you very much.